In this video, we're going to take a look at some of the concepts around vectors. And vectors are really great asset to us because they represent sort of a super number. As probably you remember back from early math when we talked about different kinds of numbers. So counting numbers, integers, real numbers, complex numbers, and a vector is also in that category of being a special kind of number because it's a number that comes with direction. So if we were going to describe the velocity of something, for example, we would state it with a speed and a distance. So speed is a scalar quantity because a speedometer doesn't tell you which way you're headed, for example, but it does have units. So when we add vectors together, they don't add like 1 and 1 is 2. Direction is obviously very important. So for one-dimensional vectors, if they are parallel, as they are in this case, then we can simply add them together. So in this case, if the directions were something like go 8 kilometers east and then go 6 kilometers east, the result is 14 kilometers east. But if the directions were go 8 kilometers east and then go 6 kilometers west, then the resulting displacement, which is the difference between where you ended up and where you started, is only going to be 2. And we would call this alignment anti-parallel. So if we're at right angles, then we have some other older tools that we could rely on, namely the Pythagorean theorem. And let's take a look at a simulation. So I'm going to duck out of this PowerPoint and pick up this simulation. So we have, excuse me, we have an opportunity where we can show the addition of vectors. So let's bring vector A out, and we'll start off with them being perpendicular. So we want to see what happens to vector A and B. So maybe the instructions are to go 10 clicks to the east. A click is a kilometer. And then we grab another vector, and the instructions for that were to go, say, 5 clicks north. And then we can take a look at what the sum of these two is. So there it is. And you can see that the vectors have translated up here. And we've specified an angle. And we also have a new vector S, which is supposed to represent the sum of the two. Let's show the values. Okay, so 10 to the right and 5 up. And Pythagorean theorem says go 10 squared plus 5 squared, and then take the square root of that. So that's where 11.2 comes from. And then here you can see that we have an angle built in. So the simulation automatically took care of that for us. So far that makes sense. Well, you know, we're going to have to do a little review of trig functions for sure in order to do this. But let's take a look at what happens when we add vectors that are not perpendicular to each other, where the Pythagorean theorem is not going to work. Whoops, not quite what I wanted. So just give me a chance to get out of this. There we go. Okay, so like all numbers, there are certain properties that we know to be true. So one is the commutative property. It doesn't matter the order that you add the vectors. And you can also add multiple vectors, but each time we do this, if we're drawing them, we're going to draw them from tip to tail. What that means is that if these were instructions, say, to get to some important tourist destination, you're going to take the instructions one step at a time, and then you'll pick up instruction number 2 where instruction number 1 left off, and so on. So when we see we're adding V1, V2, and V3, V1 goes up here, and then we tack V2, like click and drag, and put it right at the end of V1. That's the tip to tail method. And then same thing down here. And we put V3 on the end of V2. And then the resulting vectors where we go from the origin, the starting place, to the end of the last vector. Right. There's also the parallelogram method, which I'm not really that fond of. And then we come to adding vectors that are not perpendicular to each other. And how do we do that? And the answer is, well, we need some help from trigonometry. And I'm going to walk through this, an example in a few minutes. But so the main idea is that the X and Y coordinate axes are perpendicular to each other. And perpendicular means independent. It means that you can move along X without moving along Y. It's not required that there's motion along Y. They are independent of each other. And so when we go to add vectors V1 and V2 together, we can't just add their magnitudes together. Magnitude would be how long they are. What we need to do instead is break them into components. For example, F1 or V1, sorry, is pointing at about a 30-degree angle. But if we use some right angle trigonometry, we can find out how far V1 points along X and how far it points along Y. Those are called the X and Y components. And if we do the same thing for V2, well, then we're going to have components that are along X and components that are along Y, and those we can mix. But because the length of the vectors are not along the same line, then it's not going to, be a result that's easy to find. We're going to have to do the work. Okay, so some tips. Draw a diagram, add the vectors graphically, choose X and Y axes, resolve the vectors into their X and Y components. I'll show you how to do that. Then get the components and then add the components and then recombine into X and Y. So this is a nice slide. You might want to keep this one handy. Okay. So the next video is going to walk through an example.